G'day team, welcome back to another video. So we are continuing on with our trigonometry work. We've now sort of deep dived a little bit into the three main trig ratios. So we've got our sine, our cosine, and our tangent. But we can actually have a look at some reciprocal functions. So I want you to think back to a few videos back, term one for my students. When we looked at normal reciprocal functions or typical reciprocal functions, what did they actually look like? So we're mapping x and we're mapping that to a reciprocal function. I'll give you a quick moment just to have a think about that. All right, so hopefully you guys remember that it is 1 over x. Okay, so that is our reciprocal function. So we can apply this logic to trig functions as well. All right, so this is what we're looking at here. All right, so sine of x goes to 1 over the sine of x, and we call this the cosecant. All right, so we have three syllables or three letters, so CSC of x, that's our cosecant, which is the reciprocal of sine of x. Cosine of x to 1 on cosine of x, we call this the secant, okay, so SEC of x. And tan of x goes to 1 on tan of x, which is actually cosine of x on sine of x, because tan of x is sine x on cos x, and we call this the cotangent, which is COT of x. Okay, so we've now got cosecant, secant, and cotangent. Okay, really important that you're not getting confused, because sometimes you see cos in cosecant and you think it's 1 over cos. It's actually 1 over sine. So just bear that in mind. So an example of a question we've got: cosine of x is equal to 3/4 from 0 to pi on 2. Find the remaining 5 trig ratios. So that means finding sine, tan, cotangent, cosecant, and secant. So one thing you need to remember in these questions is we've got to look at what quadrant we're in. Okay, so because we're in quadrant 1, all of our values will be positive. Okay, so no extra work needs to be done. But if we were looking at, say, the second quadrant and cosine were negative, then it's really important that we take that into consideration as well. Now, the easiest way to solve these is actually going back to the roots of trigonometry and using a right-angled triangle. So I'm going to draw one in there. Oh, we got a nice yellow one. Let's change that. No fill, just so we can see what's going on. All right, so I've got an angle x here, okay? So cosine is actually defined to be the adjacent side over the hypotenuse. So if we're going to label our sides, that should be A, and that is H. And we'll make that one a capital A, just for what we're doing. All right, so cosine of x is defined to be adjacent over hypotenuse. So if that's adjacent over hypotenuse and that's 3 over 4, that means adjacent is 3, hypotenuse is 4. All right, now using Pythagoras, we can find O. So we've actually got O squared, so that is going to be the square root of 4 squared take 3 squared. All right, so that's our side O, so that means O is going to be the square root of 7. So we can put that in there now too. All right, so we've got cosine of x is equal to 3 on 4. Sine of x is opposite over hypotenuse, so that is root 7 on 4. And tan of x is equal to opposite over adjacent, so root 7 on 3. Okay, so we have the one rule given and then our two main ones, and now we need to find the other three, which are reciprocal functions. So the reciprocal of cosine is our secant of x, okay? So that's just flipping that bad boy over. The reciprocal for sine is cosecant, so CSC of x is equal to the inverse of that, so 4 over root 7. And then we've got our cotangent, so cot of x, which is 3 on root 7. So now we have all 6 trig ratios just from going back to our right-angled triangle, okay? So with that, use this strategy to solve the following questions. Get used to working with cosine and cosecant, secant, sine, everything, all right? So make sure you're getting used to practicing solving these questions, all right? We'll see you guys in the next video.